Hey, today we're going to do 10.3 Part 2, Reflections. So of the 4 different movements, this is the second one, a reflection, which if you look at the picture, looks like it was flipped over that line of symmetry. So sometimes you'll see a reflection referred to as a flip. It's reflected over a line called the line of reflection or symmetry. So the line here would be like where it would fold, kind of, or the mirror, and if you folded on this line, these two, everything would match up. So this point would match with this point, this with this, this with this, this with this, okay? So we're going to tell whether the blue figure is a reflection of the red figure. The red figure is the one that's shaded for your purposes because it's not in color. So this one, if I folded on that line, it would flip and it would touch. This one would touch this one when I folded, so the blue figure is a reflection of the red figure. For this one, it looks like it's slid. It's not a reflection because it's slid over. So that one is a translation. So that one was a no. So here again, we're going to tell whether or not it's a reflection. So this one here is the line of reflection. To be a reflection, this top should have folded over to be down here. So this one is a no because it is a slide. So here's the shaded one. Oh, sorry, forgot to tell you that these are all red. This one looks like it slid again. It did not reflect because if it reflected, this side should have gone over here when it flipped over. So this one again was another slide. These are trapezoids. So there's the red one. Here's the line. I don't know why it got cut off. And this is what it's supposed to look like. So this one is a yes. If it flipped over the line, this point would end up over here. Okay, so it's easy to see the flips visually, but what about if I want to actually draw it on the coordinate plane? What happens? So you take the original. You'll notice on the original you have A, B, and C. And it did 2 different flips. It did one over the x-axis and it did one over the y-axis. So from here to here it flipped. This is the original if you want to mark it. It flipped over the x-axis this way and it flipped this way over the y-axis. So if I folded on the y, the c's should match up. If I folded on the x, these 2 c's should match up. So to reflect an image in the x-axis, you're going to take the opposite of the y-coordinate. To reflect a figure in the y, you take the opposite of the x. So here's what it looks like. If I have the coordinates for the x, whatever they happen to be, so let's say that it was the a, it was -3, 1. What happens is you take the same x, because notice that if you're flipping over the x, notice that the x's are the same, but the y's are different. This one is a positive one, and this is a negative one. So what happens is the x stays the same, and it's the opposite y. If I'm flipping over the y-axis, if you look at the C point, the y is 1 here, and the y is 1 here. So the y's didn't change, but the x was -1 here, and it was +1 here. So whichever one you're flipping over, it stays the same. So if I'm flipping over the x stays the same. If I'm flipping over the y stays the same. The other one is the opposite because it's going from one side of the axis to the other, so it has to be the opposite. So that's the rule for a reflection. Okay, let's flip it over. So we have a picture here. Remember, the original one is the one that is without the little apostrophes. The image has the little apostrophes. Okay, so it says here's the vertices of a triangle right here. We're going to draw the figure, reflect it in the x-axis. What are the coordinates of the image? So if you flip over the x, x stays the same, opposite y. So same x, opposite y. All right. That was the same. That was what I wrote on the other side. Same x, opposite y. So if I look at the coordinates up here, the new a would be same x, and instead of a positive 1, it'll be a negative 1. The new b will be the same x, because it's flipping over the x, and a negative y. And the new c will be the same x, 6, and the opposite y, which will now be negative 3. And then, of course, it's already drawn, but you would draw it after. So I would probably put the points first and draw it after, or you can use the graph and you can count it. I'll show you both ways. Reflecting in the y. So I got vertices of a quadrilateral. Right here, there's 4 points, and they put them down here for you. Draw the figure in its reflection in the y-axis. So that means that if it's reflecting over the y stays the same, the x turns to the opposite. So we're going to have a new P, a new Q, a new R, and a new S. So we put the little apostrophe, which means the prime, right? So I'm going to make my coordinates. We said it's flipping over the y, so it's flipping over the y. If you want to go through and put all the y's the same so you don't mix it up, you can. Then go back and change all the x's to their opposite. Okay? You can do it that way. The other way to do it is when you have the original and it says that you're reflecting over the y-axis, you count how many spaces there are to the y, 1, 2, and you go that many spaces the other way. 1, 2, you would put your point and your P. Then you go from the S, 1, 2, 1, 2, 3, 4, and then you'd go the other way, 1, 2, 3, 4, and put your S. Okay, so you could count that way, 1, 2, 3, 4, and then directly across 1, 2, 3, 4, because they would have to match up when you fold it on the Y. That one is 1 away, that one is 1 away, and then you could draw your figure that way. But then you would have to figure out where all the points are. So I think it's easier to do this when it says you then have to give the points. Okay? All right, so just cross that out. Let's practice on the next page instead. So on any of these, if you want to pause to work on it on your own and then unpause just to make sure that you got it right, we can do that, okay? All right, so deciding whether or not the shaded figure is a reflection of the non-shaded figure. This one looks exactly the same, just in a different location, so that is not a reflection, that is a slide or a translation. So I take 1 point, make sure if I folded it, it would hit the same exact point. It looks like a mirror image. Then that one is a yes, a reflection. Here's the top of it here. Now the top is down here. So if I fold that in half, they will meet up. So that one is a reflection as well. It says draw the figure in its reflection over the x-axis, identify the coordinates. So anytime it says identify the coordinates, I prefer to do the coordinates first because I think it's easier to do the same x opposite y at the beginning and then draw it, than to draw it and then have to count where the coordinates are. So we have to draw the figure first. So that was 1 up 2. Make sure you label it. B is 3, 2. C is 1, 4, and you draw it. So it's a triangle. And now we take this and we do same x opposite y because it's flipping over the x, so the x stays the same. So all the x's are the same. And if you feel like you might mess it up, then put all same x's right away. Then go through and put all opposite y's. Now draw it. And it should be flipped over my x-axis, right? Here's my x-axis. Should flip over that. So 1, -2 is A prime. 3, -2 is B prime. And 1, -4 is C prime. And it should look like it flipped over. And it does. Okay? Same thing for the quadrilateral. W, X, Y, and Z prime. We are going to have to put the points, so let's just put all same X's, 3, 3, 1, 1, and then let's do all opposite Y's. Okay, whatever one is flipping over stays the same, the other one is the opposite. So we have to draw the original. 3, 1 is W. 3, 4 is X. 1, 4 is Y. And 1, 1 is Z. Okay? Then I'm going to draw the other ones, and it should look like it flipped over this. I'm going to go 3, -1 for W prime, 3, -4 for X prime, and 1, -4 for Y prime, and 1, -1 for Z prime. Okay, let's draw it. And it's hard to tell with a rectangle that it flipped, so you have to look at the points and the letters, and then you can tell that it flipped. So Z would have to match up with Z. All right, now we're going to draw over the Y. If we draw over the Y, that means the X is the opposite, excuse me, and the Y stays the same. J, K, and L. All the Y's are the same. 4, 0, 4. The X's should be the opposite. -3, -3, -2. We have to draw both. So we go 3 over, 4 up is J, 3 over, 0 up is K, 2 over, 4 up, well, that's skinny triangle, is L. And now we're going to draw -3 up to 4 is my J prime, -3, 0 is my K prime, and -2, 4 is my L prime. And it should look like it flipped over the y-axis. Okay? Remember I said you could do it the other way where you draw first. So you could draw 2, 2, and that's your M. 2, 3 is your N. Connect it in the order that you're doing it. 3, 3. Sometimes people get confused about the order. And then 4, 1 goes here, and then you would have to connect that one to there. Okay? Now you could say M is 1, 2 away, so we go 2 in the opposite, and then I got M prime. N is 1, 2 away, 1, 2 away, and you have to make sure they go directly across, same distance in the opposite direction from your line of reflection. 1, 2, 3, 1, 2, 3, so there's your P prime. 1, 2, 3, 4, 1, 2, 3, 4, there's your Q prime. So you could draw it like that, but then you'd have to go back and figure out the points anyway. Or you can do the points again this way with all the same Y's and then opposite X's. -2, -3, and -4. Okay? Or you could go over here and see where they are on the graph as well, or double check. Okay? In a pinball game, when you perfectly reflect the ball off the wall, will the ball hit the bonus target? Okay? So if it's going to reflect over when you hit the ball, so you want to hit the ball here, it has to reflect over the x-axis. So it would go 1, 2, 3, 4 away, 1, 2, 3, 4 away. It would be up here. So that would be a no. It hits 2, 4 instead.